Intermediate Algebra for Statistics, using the square root property to solve quadratic equations, Part 2. Lesson objective: use the square root property to solve quadratic equations. We'll begin with an example. Example 5. Solve x minus 5 divided by 2 quantity squared equals 31 divided by 4. Solution: our first step is to eliminate the square, and using the square root property we now can write the equation x plus 5 divided by 2 equals plus or minus, don't forget your plus or minus, the square root of 31 divided by 4. Our next step is use the quotient property to split the square roots up. So we have x equals 5 divided by 2 equals plus or minus square root of 31 over square root of 4. And we know square root of 4 is a perfect square, so now we have this equation. Next we want to subtract 5 divided by 2 to both sides. And now since we have the same denominator, we can subtract these two fractions, and we are left with negative 5 plus or minus the square root of 31, all being divided by 2. So this is two solutions. This is negative 5 plus the square root of 31 divided by 2, and this is negative 5 minus the square root of 31 divided by 2. To check our answers, we can store each result as x and then check that the quantity x plus 5 over 2 squared equals 31 divided by 4. Now 31 divided by 4 is the same thing as 7.75. So using the graphing calculator, we type in the first solution, negative 5 minus the square root of 31, that being divided by 2. We hit the store key, which is STO, and then we hit the X key. Now what this does is this saves the number n for x. Next, the left hand side of the equal sign was x plus 5 divided by 2 quantity squared, and when we substitute our x that we saved here by using the store feature, we see it's equal to 7.75. So it checks. To check the other solution, we do the same thing. Negative 5 plus the square root of 31 being divided by 2. Hit store, hit x, hit enter, and you get 0.28388, so on and so forth. And again, typing in the left hand side of the equal sign, hitting enter, we see it equals the right hand side of the equal sign. It checks. Example 6. Find the x-intercepts of the parabola f of x equals 2 times x plus 6 squared minus 18. Solution: to find the x-intercepts, we let y, or f of x, be 0, and we solve for x. Now solving for x means we need to get the x variable all by itself. So we will need to cancel the 2, the 6, the square, and the negative 18. So we have 4 different operations going on here. Which one do we do first? Imagine that we have an expression, not an equation, but an expression, and we knew what the value of x was. Let's say x was 5. What would we do first to evaluate the expression? Well, the first thing we would do is we would take x, or 5, we would add 6 to it. Next, following the order of operation, we would square, because we do parentheses first, then we square. Next, we do multiplication or division, so we have multiplying here. And then our last step is to subtract, because the order of operation says the last thing you do is addition or subtraction. So this is the order of operations: parentheses, exponents, multiplication or division, addition or subtraction. Now when you're solving an equation, you follow the order of operation in reverse. Addition or subtraction comes first. Next becomes multiplication or division. Next will be powers, and last will be parentheses. The first thing that we want to do is we want to undo the subtracting of 18. So the subtracting of 18, the inverse of that is to add 18. Next, to undo multiply by 2, we do the opposite. We do the inverse. We divide by 2. Next, the inverse of squaring is to take the square root. And then our last step, to undo the addition of 6, we will subtract 6. So solving equations, we follow the order of operation in reverse. So to find the x-intercepts, we set f of x equal to 0. We solve for x. Our first step is to add 18 to both sides of the equation. We get 18 equals 2 times x plus 6 quantity squared. We cannot distribute the 2 because this is being squared first. So the next thing we do is we get rid of the 2. Since it's multiplying, we do the opposite and divide. We get 9 equals x plus 6 quantity squared. Now we need to undo the square. We take the square root, and using the square root property, we have plus or minus 3 equals x plus 6. Last, we subtract 6 to both sides, and we have negative 6 plus or minus 3. This is two solutions. The first one will be negative 6 plus 3, which is equal to negative 3, or x is equal to negative 6 minus 3, which is negative 9. So to answer the question, there are two x-intercepts, x-intercept at negative 3 and an x-intercept at negative 9. And here we have the order pairs. To check this, we'll begin for the solution of negative 3. We take the original equation. Everywhere we see an x, we substitute a 3. We follow the order of operation, and the left-hand side should equal the right-hand side. So doing parentheses first, negative 3 plus 6 is 3. Next, we square. 3 times 3 is 9. Next, we multiply. This becomes 18. And last, we subtract. 18 minus 18 is 0. So we have the left-hand side equal to the right-hand side. It checks. For our second solution, x equals negative 9. Again, we start with the original equation. We substitute negative 9 in for x. This time we get 2 times negative 3 squared equals 18. Negative 3 squared becomes positive 9. 2 times 9 is 18. And again, we get left-hand side equals the right-hand side. It checks. To verify using the graphing calculator, we can type in the equation in y1, hit graph, look for the x-intercepts. This looks like negative 3, this looks like negative 9. We could use the table feature. When x is negative 9, y is 0. And when x is negative 3, y is 0. So it checks. Example 7. Find the x-intercepts of the parabola f of x equals negative 2 times x minus 7 quantity squared plus 20. Solution. Just as before, we set f of x equal to 0. Next step, we subtract 20 to both sides of the equation. Next, we divide by negative 2. We get x minus 7 squared equals 10. Using the square root property, we now have x minus 7 equals plus or minus square root of 10. Add 7 to both sides, and we have this solution. Again, there are two x-intercepts for this parabola. So we have 7 minus square root of 10, comma 0, and 7 plus square root of 10, comma 0 for the order pairs. Now we can use the 0 feature on the graphing calculator. You hit second trace, which is calculate, and go to 0, and we can approximate the x-intercepts by using these decimal approximations to 2 decimal places. So again, type the function in y1, hit graph, hit second trace for calculate, go to 0, and we can estimate this x-intercept. 7 minus square root of 10 is the decimal equivalent to 3.84. And for the other x-intercept, 7 plus square root of 10 is approximately equal to 10.16. So it checks. Thanks for watching.